Yo, what's up, guys? Welcome back. Episode 38. Yeah, we're gonna get straight into it. Let's do our Pokemon start of the day. Come on, 38. What we got? We got a Ninetales, like what I said yesterday. Ninetales sound. I love Ninetales. Bleh! Bleh! Bleh. I don't even know how to do it, but bleh. Interesting. But yeah, what a great Pokemon. Yeah. So I got a hot chocolate here. It's freaking freezing in here. I realized my roommate has set the air conditioning, cooling, heating, whatever, to cooling or to cool down to a specific degree. So what's up? Yeah. Dude, you know you had it set to cooling? It was freezing in here. What? Dude, you left it there and I've been freezing. I couldn't figure out why until I looked. Bro, you wanna come be in my video? You wanna come have a special hello? Yeah, bro, you can like say hello to the webcam, dude. Like,
hey guys, I just met Governor Pritzker like an hour ago. That was pretty cool.
big time.
Max has hot chocolate.
Yep. Got some hot chocolate. Making my video, dude.
Yeah. I heard my roommate turned it to me. He looked at me.
Yeah.
Shoddy, fuck off.
Alright, man. So we're gonna get straight into it. Yeah, let's do hot chocolate's gas. Let's do another stack problem. I wanna keep looking at a stack only because I don't know, it's tough for me to wrap my head around it, to be honest. Let's do the minimum as make parentheses valid. Interesting. Okay. Where it can be written as A concatenated with B, where A and B are valid strings. I was thinking this maybe could be solved with a dictionary, but I don't know. For example, if S, you can insert an opening parentheses to be pretty much we just gotta count the parentheses. So we gotta loop through the string, so for char and S. when they want to hire you. I'm pretty confident you can just do this with a hash map, honestly. You don't even need a stack, but we're gonna attempt the stack. Let's just attempt to solve it with a hash map, you know, just for better practice, because why not? For char in range length s. We want to initialize our dictionary here. Minus the dictionary. Then we want to loop through. If char in my dictionary. Char in my dictionary, then minus go dic s char plus or equal to 1, else we make my dictionary as char equal to 1. The hot chocolate's better with milk, man. It's definitely better with milk. I mean, we know we're only going to be working with either I guess we can just do an if statement. If my underscore dic dot key let's figure out how to dictionary Python. Do value 1 is equal to my underscore dic dot get. We can do sorry, not name. This one. Value 2 is equal to my underscore dic dot get. This one. You could do if value 1 is greater than value 2, then value 1 res is equal to value 1 minus value 2. Else we want to do res is equal to value 2 minus value 1. Guess we just want to return res. I think this should work. I actually don't know. What am I doing wrong here? Got if s What if not S? That's the same thing. Not S, return 0. Oh my god. Bro, what is going on here? Let's just do it this way. Bro, I don't understand. Unsupported operands for int and none type. So if one of them is none? I think that's what the issue is, if one of them is none, because technically one of them could be none. So I think we've got to do it the other way. Let's go dick. Char. Char is equal to, how do you do it again? You gotta get char 0 plus 1. One is equal to 9. Return value 2. Value 2 is equal to 9. Return value 1. Bro, what is going on here, bro? Like, I literally have no idea, bro. Right. Yes. Let me change this to this. Oh, this is insane. Finally. Okay. There we go. Hopefully this works. Bro. So the reason why this doesn't work, actually. Wait, expected for output 0. We've got 3 and 3. So I didn't think about that, about the order. I think that's why we use a stack, because of the order. Maybe it's a metonic stack because of the order, right? This works when we're just tracking them like this, but man. Let's think about this. How we do it using a stack. Well, we got to think about the order, so that means we got to think about the indices. Got to think about the indices. We gotta think about the order here. So if we got sort of using a hash map, I think we might be able to just use a string. So maybe if we keep a count, right? So we have count 1. Man, I was doing a workshop earlier, and man, having a mouse is just goated. Like, okay, we have count 1, count 2, right? We count the opening ones, and then we count the closing ones, right? So then we do we loop through with a for, right? Like what we did before. We loop through each value. And then if we see a thinger, we add to our count. Else if we see a closing bracket, then we increase our count. But since we saw a closing bracket, the thing is, we only... How does this return 4? Like... Oh, okay. It's because this returns 4 because we have the closing here, so this one's valid. And then we have 1, 2, and then 3, 4 here. That's why we return 4. So if we see this, we add 1. Also, if we see this, we add 1. Then we want to add some other condition to trying to think. Yeah, I need a glass of water. Let's say if we see this, I think we're going to want another if statement below this, right? We check if our open count, or if our open count is greater than 0, then we can move. So if our open count is greater than 0, we move. We decrement from our open count. I'm not even going to write that again. Or count 1 or whatever you want to call it. And then else, we just increase our close. Plus equal to 1, we increase our close. Just point count 2 over here. I was just trolling in the group chat, dude. So funny. I think that should work. And then obviously after this we would return our C1 and our C2, but plus. Sorry, texting, and then I'll do this for char and s. Oh my gosh. Okay. Okay. We want to check if our char, if char is equal to this, then we want to increase open is equal to 0. Oh my gosh. One, count 2. This reps opens, and then this reps closes. We just want to increase by 1. Else, oh sorry, not else. Else if char is equal to a close, and we want to just increase our count 2. No, we don't. We want to check an if. I'll check if our count 1 is greater than 0. Then we want to decrease our count 1. If it is, we want to decrease. Else, we want to increase our count 2 by 1. And we just want to return count 1 plus count 2. See what that looks like. Got our thing over there. Oh. Oh, jeez. Access count. Oh, counts. We just want to decrease our count 1 here, yeah. Damn. How did I just do that in 2 seconds? Oh my gosh. That's funny, bro. I don't understand how you can get any faster than that. I mean, bro, this is an O of N operation, but like, I mean, technically this is meant to be a stack, so we're going to think about it in a stack, so how to comment out blocks in Python. Can't even remember. Okay. Let's do this so we can look at this. Think about, in a way, how we can use this as a stack. So obviously we want to create our stack. Put char in S. How do we want to replicate this using a stack? We want to do think about this using a stack. I'm actually not too sure. Right. We have our stack. Yeah. We have our boom, boom. So if we loop through, right? We add here, we add here. So we have to always think about an opening first, right? These ones don't ever matter, so we got to think about an opening. So I think we go through this, we add every single this to a stack. Then when we see this one. Literally, this doesn't seem like the way to do it, but the only way I can think about it is that if we use a stack to track the openings, and then we pop every time we see this. So then we pop from the stack when we see this. And we don't add until we see an opening. Every time we pop, then we do it. And then how will we return the value? Sure, let's check out solutions. Another stack. Let's see it with a stack. Trying to if length stack is equal to 0, stack that up and jar. Continue. Prev is equal to stack.pop. If char is equal to C and prev is equal to O. I'm kind of confused what this code is actually doing. That's usually what I said. So the internet is telling me, but then what's the point of using a stack? Like, creates unnecessary complexity. Like, so what are we doing here? We have, and this is C. We have a stack. We're looping through each value. So then if the length of our stack is 0, then we append. We continue. Then we pop. So stack.append prev, stack.append char. I don't even understand what this is doing, to be honest. I know we're looking to reach value if there's nothing inside the stack, we append. But I don't understand why we're just constantly like we're popping and then we're appending. I don't understand that. Like, because then what the hell are we doing? Like, it's interesting. I didn't really think about it like that. For char and s, if the length of the stack is equal to 0, we append. Then we pop instantly. For char and s, we'd append. So we'd append our first value here. We continue. Alright, so then we go to the next one. For char and s, right here, right, if length stack is equal to 0, stack.append char. Stack is at 0, so then we pop prev stack.pop, we pop. So then we pop this from the stack. Right. We check if char c and prev is 0, no, then it's not the same, so then we append both back. So then we're here. Then we have here. Then we go here, we wrote this value. The length stack, no. Prev is equal to stack.pop. Prev is equal to stack.pop, so we pop from here. This. If char is equal to c and prev is equal to o. If char is equal to c. Our char is equal to c. Yeah. Sorry, if char is equal to c. Equal to c and prev is equal to o. And we pop, but no, it's not, because our char is equal to o. Our char is equal to o and our prev is equal to c, so that's wrong. So then we'd append both. So we'd append. Oh, sorry. We append prev. We'd append prev first, so we'd append this back. And then we'd append an open bracket. Then we go here. We're number 4 here. So this is our char. We pop from the stack, so we pop this one. So now if our previous, so if our char is equal to c, so we got c here, and our prev is equal to o, then we continue. So we don't add these two back to the stack. So this is safe right here. I'll just cover it. So then we go to here. We add to the stack. No, we don't. Sorry, we pop again. So now we're looking at this one. Again, we pop. We realize that they're both not the same. So then we add them back. And then we add boom, boom. Then we go to our final value here. We pop from the stack. And we realize that, then we add them back. So then we add boom and boom. So obviously we got one value here, we got two values here, we got 3, and we got 4. So we would return the length of the stack. We'd return 4. That's an interesting way to think about it. I just don't understand how people come up with these solutions. Like, you know, it's like very impressive that, like, to me at least, that they can come up with that like on the spot. You know, like, unless you've seen this problem before. Again, this is like an easy stack problem. You know, like this, to be honest, probably should be an easy problem, but it's like, you know, think about the stack approach. It's just like, maybe I don't spend enough time thinking, but I'm more of like a visual learner. So it's like, you know, if I haven't really seen the problem, it's tough for me to, maybe that's bad for me. You know, I want to be a good engineer. Maybe I should be able to think of that. I don't know. But let's put that into use. Though I think you can use a stack the same way. I mean, I was looking over here at a different way. The same kind of way that we But I think as well that you can use a stack in the same way as this one. Like, you know, in a different way though, where you can we do for char and s. Char is equal to this. Kind of the same way. One is equal to 0. Count 2 is equal to 0. Stack to open char, right? Then we do else if stack minus 1. Else if char is equal to this, and stack, the top of the stack is equal to this, then I guess we can stack.pop. We can pop from the top of the stack. We don't add that value, right? Else we just stack.append char, and then we return the length of the stack. I think that should work. we need to keep track of the count. Next on pop. I'm doing it on the same line, that's why. Jesus, dude. If stack is not empty and stack minus 1 is equal to this, next on pop. Oh. Fuck the indenting here. Don't need this. What did I do wrong here, bro? Why wouldn't this work? Oh my god, we're checking the same. That's why. Alright, bro. Stupid little mistakes, bro. Nice. Apparently the stack solution is faster. I don't understand, but that's right. I would have thought it would be slower, but now let's think about it in the way that we did this, right? Or I guess is it kind of... I guess it's the same, isn't it? No. This one here, we're checking for char and s if char is equal to this. The stack is empty, so it's not going to do anything. I'll stack that append char. We'd append these. We'd see this. Char is equal to this. We'd append that. If this is here, then we'd pop the top, not add this one, and then we'd add these two. But in the other way, we're checking let me put this over here. We're checking char and s. Char is equal to a open bracket. Open bracket. Then we're just appending to our stack, right? One is equal to minus cat c equal to this. Charge equal to this. Stacked out append here. Okay, wait, we have to check if the length of the stack is equal to 0. Then we just want to append stacked out append char. Right? Then we want to check, well, we want pop, stacked up pop. Then we want to check if want this to be our previous, right? So our previous value. Then if we okay, so then we want to check if our current char is equal to C, our previous equal to O, and we found a match, right? Else, if we haven't, we just want to, else if we haven't, add them back, right? And we want to add them back where we add stack.append jar, stack.append prev, and we want to return the length of our stack. What am I doing wrong here, bro? What is going on here, bro? Oh shit, that's why. We're forgetting how it continues. Oh, it's just gonna keep going through the loop. Why would this here get 4? Oh. Because we're appending the wrong way. That's why, bro. Stack.append prev stack.append char. Because we need to keep our order. We're switching up the order every single time. There we go. There we go. So the difference between these two optimized methods is that this one matches and then removes the match, and the other one, what does the other one do? The other one loops through each value and just compares the top of the stack to our current value. So technically it does the same thing, but you know, just in like a little bit different of a way. You know, this one we're like adding each value, taking it off the stack, adding it, blah blah blah. The other one just compares the top of the stack to the current value that we're looking at. Well, yeah, I mean, the other one, actually, technically, the other one just appends open brackets, so we're only keeping track of open brackets. Are we? Yeah, I have to look at the code again. Another one, if char is equal to this, we just append. It's just really checking every time we have a closing bracket, and checking the top of the stack, and then removing it. So, yeah. Quite similar, but just a little bit of a different tweak. Interesting problem for sure. Interesting problem for sure. Let's check out this one. Doing a lot of stack problems the past couple of days, man. Jeez. Given a string S of this and this. Yeah, working with parentheses or brackets or whatever, you task to remove the minimum number of parentheses in any position so that the relevant parentheses string is valid and return any valid string. String is also valid. I'm confused. Oh, okay. I understand. So again, I think this can be kind of... I think this could be done... Okay. This string is valid, definitely. I think this can be done using a string as well. Actually, maybe not. Maybe not. No, I don't think it can. I think you need a stack for this one. I think. Let's take a look. Sorry, solutions. Python 3. Oh, these two approaches without a stack, so you can do it without a stack. I thought you couldn't. Maybe you can. So I guess we're kind of doing the opposite here, where we're getting rid of strings that aren't pairs. So... We're getting minimum removed to make valid parenthesis. I don't think this is refreshed. Yeah, I think it's the opposite, literally. Trying to think here. Trying to think of it how we can do it without strings. Each prefix. trying to think.
We had this one. We have a value here. We had this one. So each prefix of parentheses has a number of parentheses greater or equal to. Trying to think how we would keep track of this. That's what I'm trying to think about in my head is that how I would keep track. Because technically we're removing parentheses. So like if we're here, we're here. Well, I guess we're moving this one. But it's like, how do you know to remove that one? That's the thing. Like, because with the stack we can only check the topmost value, right? So either if we just ignore closing parentheses at all, so I'm thinking we loop through, maybe, we ignore all closing parentheses, unless the top of our stack is one of these. If the top of our stack is that, so what I'm thinking is that we loop through each value. If it's a letter or whatever it is, then we add it. Then if we see one of these, see an opening, then we can add a closing, and we keep going through. But only if our opening is greater than 0. If our opening is greater than 0, then we can add it, and if not, then we just don't add it at all. That's what I'm thinking, is without a stack.
So I guess we can do that right now for char and s. If char dot is alpha, I think that's how you do it, or char is equal to this is alpha, then we, I guess we can just transfer stack. I guess we can use a stack here. I mean, actually, let's just do res is equal to this. Yeah, I'm gonna sneeze. And that's equal to char. Does that work? I don't even know. Print res. I don't know if that's how you do is alpha. What you mean is alpha? Like that could be it. Is alpha? strings are immutable in Python. So can you not add this? I don't know. Maybe we will need a res. Need an array. Yeah, strings immutable Python. Okay. Where's the pen char? Let's print res. Leetcode. Okay, good. That works. I guess also if our char is equal to a open bracket, then we can chars open char is equal to 0. Char is equal to this, then we can open char plus or equal to 1. And obviously we want to append, so we want to do res.append char. And then also char is equal to closing bracket. You have to check if our open, let's just do open count. I don't know why I'm doing open char. Check out open count. It's greater than 0. If it is, then we can append res.append this one. Else we just continue, I guess. And then we decrease our open count minus equal to 1. Then we just return our res. Return res. We're doing else. Just do else here. Else if else continue. Count. Okay. We have an edge case here, so I don't know, how do we solve this edge case? Like, Really, we'd have to reuse a whole counter, dude? There's no way, bro. Like, there must be an easier way, bro. There's no way that we would. Maybe we can make a close count. This is an interesting way I'm trying to think of. We can have a close count here, close count, plus or equal to 1. Have here, if res is equal to none, while close count is greater than 0, then we can do res.append res.append there's probably some other edge case, bro, like res.append oh sorry oh shit, I'm messing it up. I'm adding the opening parentheses. Okay. Wait, sorry. If res is equal to none, and our sorry, we don't even need our close count. What the hell am I doing? Okay, res. If our open count is greater than 0, wait, hang on. I have to I have to rethink about this. Okay, hang on. So we come through here. You know, we don't add these, but we see the opens, right? And our open count. Okay, so if it's balanced, our open count would be 0. But if not, I think every time it should be balanced. I think. Print open count. Let's try it out. Bro. So in this case, open count is 2. It's okay, 0 everywhere else. Okay. So if our open count is greater than 0, we just want to return none. There's no way this works, bro. Like, there's gotta be something else now. I'm messing it up, probably, for sure. Like, bro, there's no way this accepts. Like, no shot. Yeah, I knew there was some other. Let's use this test case. What do we do here? Okay. So without this, would this be good? I'm a little bit confused. So we have 4 brackets here, right? No, we have 3. So we have 3 opens, 2 here, close. So that's why we have to pass from to the first pass and second pass. Interesting. So I only did first pass, checking for extra these ones, right? Now we gotta do the same thing. Do a second pass and add extra of these things. Oh, sorry, the open. Alright, so then I guess we can close count is equal to 0. This f res is equal to this, our final res. Our final result is for char in res. But we want to go from behind, right? Reverse res. Okay, if char dot is alpha, we just obviously want to append. Final res dot append. We have to reverse it at the end again, yeah. Final res dot append. Else if char is equal to a closing bracket, then we want to increase our close count plus or equal to 1, and then we want to final res dot append char, right? Yeah. Else, if our char is equal to the other one, then we just want to continue, right? Track our openings, so start from here is alpha, we keep going. If our char is equal to this, we want to increase our close count by 1 and append. Char is equal to this. And we want to check if char, if close count is greater than 0, then we can append final res dot append char, then we decrease our close count by 1. else we just ignore it and continue. And we want to return. We want to return our array. Return our dot join reversed final res. There we go. Check. Whoa. Well, we did it. Solution. Solution without stack. Is I think it's O-van time and O-van space. Or what is time and space complexity of this algorithm? I'm not sure what the space would be here. I think it is they're both O-van, but I'm not. Yeah, they're both O-van. Okay. What would be, but I don't know what O of n squared space would be. Okay. Alright, whatever. I think they're both O of n. Approach. Use two passes to check for valid open parentheses and close openings and closing parentheses. I don't know how to spell this, bro. Like, okay, cool. Cover, please. Well, we thought of a solution, so that's good. Okay. Now let's figure out how to use it with a stack now. So I'm still not really 100% sure how we do this with a stack. I think to do this with a stack, we'd have to push indexes to remember where we're at. Because we could. Then how would you know that it's a? Yeah, I think that's what we're gonna do. Actually, we're gonna try it that way. It's the way. What the hell? Why can't I click enter? Let's reset the default. All right. So let's create a stack. So I'm thinking that we can. If I'm right, this is kind of impressive. I'll be pretty happy, right? So we have our stack. Right? We have our string, right? So on our stack, we just keep track of our values, right? So then we have a res array, right? So we loop through, we add all letters, and then if we see a parenthesis, if we see an open, we add it to the stack, right? We add an opening to the stack. But we add the index of where this occurs. So we 0, 1, 2, 3, so this occurs in index 3, but it's this, right? Then we go through here, we add this to a stack. This would be index 5. Right? Then if the top of the stack is equal to the current char, then we pop wait, hang on. And we pop. I mean, this will work. Like, not actually do the problem, but I think, well, the way I'm thinking about it, we pop this from the stack, right? We don't add it. Then we see another one, then we pop this from the stack, right? No. I don't think that would work. I'm trying to think of a way that we can we do this all in a stack? That's the thing. I don't know. I don't think we can do this all in a stack, but we gotta somehow use the stack to keep track of the parentheses. I'm kind of curious in Python. Let's say we have 1, 2, 3, 4, 5, right? And then we do res.remove res2. And print out res. What does that do? Does it automatically resizes, I'm pretty sure, right? Like, okay, so it automatically resizes. So then what if we do res.add res, okay, res.insert I think this might work if we can delete, right? Because then if we keep adding to the res, right, and we keep track at the top of the stack, then we can just keep deleting from each value. That's what I'm trying to think. Is that if we're looking through the stack, you know, we can delete. So we have these. Hang on, I'm trying to think of this way, like, alright, so technically we loop through this, right? If we could delete, res.remove, and we just do, you know, res2, right? This works, it automatically resizes. We can go through and we could have a result array, right? Keep adding values, right? So we add L, E, E, and then when we see a parenthesis, we add one here, right? And we still add it, right? So we have our parenthesis. I'm going to make them in red just so it's a little easier to notice, right? Then we add our T, right? Then we see another parenthesis, so we add it in red. Okay. Then we add a C. Then we see a parenthesis, right? So we see, and the top of our stack is a C, right? So we must do it a different way. Because technically we can't just add that to the stack, because then, you know, how are we going to remember this is the one, you know? Oh, actually, no, we could append, we could append here, append this, but then pop this from the stack, pop the top here, right? Then we can, we're at O, so we have our O here. Then we can add a bracket, and we check at the top of the stack, okay, yeah, this is good. So then we can pop this one too, right? Then we have, oh shit. We need to add our red here. We have O. We have this one, right? Then we can pop from the stack as well. Then we have our D. We have our E. And then we can add, and then we see another one, and we add to the stack. We add to the stack. And then at the end, whatever the length is, we keep popping. So whatever the length this is what we remove. The extra that we remove. I think that might work. But I'm sure there's probably some like edge case in here that's probably incorrect, but we're gonna try this, and if not, we'll just have a look at the solution. Because this is really the only way that I can think of. Because I don't know how you can we insert a number at res? Can we insert 6 at res 2? Oh, and you can insert too. Insert 216 x with 6 should be inserted. Okay, that's interesting. I didn't know you could do that in Python. That makes it a little bit easier. So we can insert as well. So maybe we can keep track. I think we should be good. I think that should work. Like, let's just try that. So for char in S, if char is alpha, let's res.append char, right? Res is equal to this. And we can do else if char is equal to the opening parenthesis, then we can we want to add it to the stack. Just do char. Then obviously we want to append as well. Res.append char. Else if char is equal to this, and stack. Also, if char is equal to this, sorry, to closing. We want to check if the stack is not empty, and if stack minus 1 is equal to stack minus 1 is equal to this. Oopity. We want to just pop from the stack, right? Because you only want to keep the values that we don't want. And then we just shit. Okay. Put char in range length s res.append append s char append s char this needs to change here. We need to append else if s char else if s char. Okay, stack, and if stack minus one is equal to this, we want to stack dot pop. Alright, we want to append to the stack. We want to just append our char. We want to append a value. If stack and if stack. And if we want s stack minus 1 equal to this, then we want to pop from the stack, stack.pop. This, then we want to pop else. That's okay. I'm getting confused with my own code and how I did. Oh my gosh. Okay, let's think about this. So I'm gonna go through this. We see this. We see the opening. We just want to add it, and then we want to append, right? So we append our res.append. This needs to be schar. Right. If we want to append our schar, so we put this here, then we add it to the stack, right? We have our T, we append that, then we have our C, we want to just append to the stack, right? And then we want to append this, and then if we see a closing bracket, we want to check, well, is the top of our stack a opening bracket, right? If it is, an opening bracket, then we don't want to add anything. We just want to stack.pop, and we want to just res.append schar. However, the other option is that if it's not the top, and we want to just keep adding. Do stack.append jar res.append stack minus 1 res.append, oh sorry, what am I doing? Res.append jar. Right, then while stack is not we want to do temp is equal to stack.pop, then we want to delete res.delete, right? Was it delete? The fuck did we do? Was it remove or delete? Is it res.remove in Python? I don't remember. Res.remove s temp. We want to just return our .join of our res. I'll be surprised if this works, to be honest. Syntax. Second, if s What is the invalid? What is wrong with the syntax? Oh, I've got the if here. If char int object has no attribute is alpha. Oh wait. If s char dot is alpha. Oh, we've got our parenthesis here. Whoops. This video's been going for a while, dude. I've only done 2 problems, Jesus, dude. Ooh, bro, we were so close, bro. We were so close. I don't know if this is working. Wow. Stack. Does that work? Well, stack is not none. Something wrong with my syntax. What's wrong with syntax? Does that work? Delete res temp. Oh my god, dude. There has to be something wrong here. That. Oh my god, I did it, dude. Oh, wow. I did it. Oh my gosh. Interesting. Wow, yeah, I did it. That's cool. I think I definitely have got stacks. Let's check out some better solutions. 100% beat. Yeah, bro, let's go, dude. Jesus, man, this guy's got so much bullshit, dude. Oh my god. First pass. Bro, he's not even using his stack, bro. Oh, push to a stack, okay. Check out Python code, dude. Pass 1 for CH and S. If CH. Okay. Dear ChatGPT user. Yeah, this is an interesting solution. Like, if Kennedy was ever kind of we have a stack pass model. If right count is greater than left count, then right. Interesting. All right. Well, that's cool. We did a solution. We completed it. I'm pretty proud of it. Nice little solution here. So, thank you. Thank you guys. I appreciate you guys watching. I will see you tomorrow.